Okay, let's look at this centrifugal pump problem. We've got a 7-inch diameter impeller here, and it says we have the performance characteristics, i.e. the pump curve, is figure 12-12, and that is this figure here. So this figure gets used a lot in various problems in the book. So that's our pump curve, and here's where our pump is sitting. We're drawing water out of maybe this tank or this ditch over here, and it's 12 feet below the pump inlet, so that's key. And we want to know if the head loss is given as 6 feet between 1 and 2, so between the surface of the water here and the center of the pump here. So that head loss, we could figure it out if they gave us enough information, but they just gave us the head loss from 1 to 2. We want to know if we're going to expect cavitation. So think of the approach. When they ask about cavitation, they're asking about NPSHA available, so the net positive suction head that's available. Remember, so the net positive suction head is the head that's behind the pump to help the pump get primed or help the pump get going. If there's not enough of it, then the cavitation or boiling of the water will start. That can damage the pump. So remember, we have atmospheric pressure helping behind us. We have the depth of or the height of water behind us. In this case, it's a negative, so it's not really helping us. We have to pull it up. That's not helping us. The head loss is not helping us, so that's a negative too. And then it all has to be greater than the vapor pressure of water. So that's why we always have this minus PV over gamma. And remember, PV is a function of temperature, right? So water boils more easily at low temperature and less easily at high temperature. So water would boil at 1 atmospheric pressure at 212 Fahrenheit. Our water is 100 degrees Fahrenheit, so it's well below the boiling point. But if this vacuum forms by pulling, that's needed to pull the water up, is sufficient, it'll boil at 100 degrees Fahrenheit. So that's what we want to know. That's really what we're asking, is the net positive net positive suction head that's available greater than what's required by the pump. So what's available is just from this equation. Remember, we use absolute pressure terms here because we've got to use basically atmospheric pressure and vapor pressure here. So we need to use the absolute terms here, not the gauge pressures. So if we look at the chart, we're interested in the required net positive suction head for the pump. So basically this problem is asking, is NPSHA greater than NPSHR, the required net positive suction head by the pump. So that's this scale over here, and we're operating at 200 gallons per minute. We go here, like so, and we go over here, like so, and we're talking about 13 feet of head is needed to get this pump going without cavitation occurring. That's basically all we need this figure for in this case. So after that, this is what we're asking, as I just said. We're going to say we need 13 feet. When in doubt, pick the bigger number, so you'll be conservative on this one. Don't want to cavitate that pump. We go to table B1, and we look up the vapor pressure at 100 degrees Fahrenheit. It's 0.95 psi absolute. And our gamma at 100 degrees is about 62 pounds per cubic foot. So we can put those in. Got our atmospheric pressure, 14.7 pounds per square inch. Conversion, 144 square inches per foot squared, 62 pounds per cubic foot. We've got our Z1, we've got our given head loss, and here's our vapor pressure. So we put all those in, and it says that the available net positive suction head is 13.9 feet. So, technically speaking, we do have sufficient net positive suction head available because 13.9 is certainly greater than 13. However, let me just add a little caveat that this is pretty close. We would have to really watch that reservoir, because if the reservoir started to dip down, we could easily make it a little more difficult, and could say it went down another foot, then you're probably going to start cavitating. So that's cutting it pretty close on this one. You'd probably want to do something to bring this water level up a little bit, or guarantee that it stays up a little higher so that you could close this distance a little. That would be your best engineering knob on this one. So that's a cavitation problem. So remember, cavitation problems are interested in NPSHA and whether or not is greater than NPSHR.